Okay, so as I mentioned, this starts a brand new section for us, a brand new kind of material, largely unrelated to what we've just done. So for some of you, this will be a breath of fresh air if you are tired of exponents and radicals. So we'll see how it goes here. In this lesson, we simplify our radicals that come from the quadratic formula. That's our last use of the word radicals for a little while here. And we multiply polynomials using something called the box method. So here's our demo. We will soon cover something called the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. Raise your hands if you memorized that. Nobody has that memorized? Used to have it memorized? We've seen it before, right? Okay, so we are not officially covering. Not doing that. All right, so we will officially cover this thing in due time. We are not officially covering it right now. But I will tell you that coming out of that quadratic formula in a few weeks, we are going to have things that look like that. You guys see the similarities, right? Like that quadratic formula is going to spit out things, numerical things that look like this. And so our job, once we've used this quadratic formula, is to simplify that thing in yellow. That's the piece we're going to do today, okay? So I'm just going to hand you things that have come out of this creature, which we will talk about in a few weeks, all right? And our job is the finishing piece, is the simplifying piece. So we're just going to read and take a look at all the work here. First step is the most important one. Suppose that I give you this, 3/5 plus 8/5. What does that really equal to? 11/5, right? I'm going to put the 5 down here. Why is it 11 on top? You just add 3 and 8, right? It's so quick, you probably don't even think about it. So you believe this equation to be true, yes? You have a lot of experience combining two fractions with the same denominator into a single fraction with that denominator, right? Today we're going in the opposite direction, a direction that you might have very little experience with. But if you believe this equation, then you must believe it in the other direction too. That if you see something that looks like 3 plus 8 over 5, you are welcome to split that into two fractions. The 3 on top of a 5 plus 8 on top of 5. Yes? It's definitely true. It seems like it's worse, right? It's less simplified going that direction, but it's going to be something we're going to want to take advantage of today. So here I have -6 plus or minus the square root of 48 over 8. This plus or minus is just a shorthand notation. It means -6 plus square root of 48 over 8, and then completely separately, -6 minus the square root of 48 over 8. We're just smushing them together. It's really two expressions combined into one. But if I see addition, then I'm looking at something like the very top right-hand side there, 3 plus 8 over 5, right? So this -6 should be in its own fraction on top of what? On top of the 8, right? Just like that 3, like both of these guys get a 5, right? So that -6 gets an 8. There it is. And there's a plus or minus in between. That's like this guy right here. And then that square root of 48 also gets what denominator? Also gets an 8. So it is there. That's the most important step for simplifying these guys. Okay, let's keep going. -6 over 8 reduces to -3/4. That's easy. This square root of 48, that's not a nice number, but we have talked recently about simplifying square roots. What nice number goes into 48? Looking for a perfect square that goes into 48. What goes in? 16 goes into 48. 4 goes in, but we're going to grab the biggest one we can. So 48 is really 16 times 3. 16 comes outside of the square root and becomes 4, right? Square root of 16 comes out as 4. And now finally, that 4 and that 8 are ready to reduce. They cancel. 4 becomes what? 8 becomes what? 4 becomes 1, 8 becomes 2. I didn't write the 1 there. It's in front of that radical 3, okay? And so this final answer here is our simplified version from that yellow thing. -3/4 plus or minus square root of 3 over 2, okay? So the key in that first step is to split into two fractions, and then you just simplify them separately. Point out a couple of other things here. Number one, if you do not split into two fractions, here's the common mistake that I see. People say, okay, -6 and -8 reduce, right? 2 goes into both. What's on top? negative, I'll put a -3, and on the bottom, 4, right? Seems reasonable. -6 and 8 reduce, -3 and 4. However, that square root of 48 now appears to have what denominator? A 4. It doesn't have a 4. What's the denominator for that square root of 48? It's 8. It is not affected by this reducing that happens here. And so that's why the very first step is to help us kind of avoid that temptation. It looks like we should be able to cross off. You can, but not until you split and give every part of the numerator its own denominator. Then they can work with the denominators separately. That was our way of trying to simplify the square root of 48. We're looking for a perfect square that goes into 48. 16 is the best. What's that? Oh, square root of 48, you could type on the calculator and you'll get like 6.9, but that is not an exact answer because decimal goes forever, right? So we're looking for an exact answer, and this is how we simplify but still keep an exact answer. So, I mean, you're right. Like you could type this whole thing in the calculator and get a decimal, an inexact but pretty accurate decimal. You could also type in our final thing here and get exactly the same decimal. Right? So we're just simplifying but trying not to lose any accuracy. Okay, the other thing I wanted to say, what was the other thing? Is that stuff inside the radical and stuff outside the radical do not interact in any way. So even though 8 goes into 48, doesn't it? I think it does, right? 8 goes into 48 6 times. You cannot cross them off and put a 6 in a 1 or anything like that. That square root, it's like a house. Anything inside the house is protected from the elements that are outside the house. Cannot mix and match. Why was it okay to mix and match here? That 8 with this 4. They were both outside the house, so that's okay, all right? Okay, let's take a look at number 2. Let's change gears and talk about multiplying polynomials. So before we talk about this box method, let me show you guys something. Suppose that I gave you this problem here. You don't need to write it, but 3x minus 4 multiplied by -2x plus 5. Do you guys have any acronyms, any like little cutesy things that you do to tell you how to multiply things like that? FOIL, yes? FOIL. F-O-I-L. F stands for first. You multiply the first thing in this parentheses by the first thing in that parentheses, and you write the answer. Outers stands for? Sorry. O stands for? O stands for outers, right? And so you multiply the things that are on the outsides, far from the middle. I stands for inners, so we multiply these inner guys together. L stands for last, right? The things that are last. So the last thing in each parentheses gets multiplied. So FOIL is how you can multiply two binomials. If you took Sandy for 095, I think she had a visual way to lobster claw. You guys, can you kind of picture it? Right. Lobster claw. So I am not a fan, and the mathematical way to say all of this is the distributive property. All we're doing is distributing stuff into parentheses. I like the lobster claw. I do not like FOIL. I'm going to try not to use that acronym too many times this semester. I'll use it because many of you are familiar with it. But the reason I don't like FOIL is that if I give you this thing down here, negative a minus b plus c multiplied by d minus e plus, minus f plus g, there is no FOIL there. There's no first, outer, inner, last. FOIL is very limited in its use. It is only something with two terms times something with two terms. Turns out we do that a lot in math, and we're going to do that a lot this semester, which is why in high school they teach a lot of FOIL. But it's limited. It doesn't let you, you can only apply it in that very special case. Well, you can. I mean, like if I asked you to multiply, this guy times this guy, I would just say, okay, that one is just C times G, and there's nothing to simplify. But that's okay. But but we're going to use something called the box method, which will allow us to multiply like in the FOIL cases, but will also allow us to multiply in these bigger than FOIL cases. Nothing to take away from the lobster claw. That also works. It generalizes. You just multiply everybody times everybody. This times this times this times this times this, and you end up kind of with the like this mutant, many clawed lobster thing. I'll do the last one in a different color here. Everybody times everybody is the key of all of this. So we've got this very robust claw in that case. Okay, so we're going to talk about something called the box method. Okay, we are up here. So we'll learn the box method since the box method is very general, not like FOIL, and will help us with an important upcoming topic called factoring. Now, here's the deal. I am not going to require anybody to ever use this thing called the box method. Some of you are going to really like it. Some of you not so much. I'm going to encourage all of you to use it at least until you see what the point is, and we're not going to get there today. So we're going to answer some questions that some of you will find the box method is like, why do we have to do all of this work? This is an easy question, but I'm telling you the box method is going to make some hard questions coming up reasonable, okay? So the box method we're introducing today, but it's really looking ahead to harder problems than we will see today. Okay, so let us multiply. Multiply this 4x to the third y to the fifth by this negative 3xy squared minus 7x cubed plus 2x squared y. Again, you already know how to do this. This is just a single distributive property, right? But you could all write down the answer right now, but just work with me here. We'll take our time. We're going to set up the following box. We're going to take that single term in yellow, 4x to the third y to the fifth, and we'll put it on the outside, the far left of this box. The green has three terms. You can tell the terms because they're separated by additions and subtractions. So negative 3xy squared goes in the top left of the box, and then the next term goes in the middle, and then the last term goes on the top right of the box, all right? And all we're going to do is find the area of each of these boxes. So we are thinking, do another color here. Like we know the area of a box is length times width, right? And so the way that I've labeled this box, the length is, negative 3xy squared, and the width is 4x to the third y to the fifth. So when I say find the area and put it in the box, you're just multiplying, right? Which is exactly what we know we're supposed to do. We saw it over here in purple, 4x to the third y to the fifth times negative 3xy squared. That is what I'm asking us to put in that box. So let's give it a shot. 4 times negative 3, that's easy, that's negative 12. X to the third times x. One vote for x to the 4. Is it x to the third or x to the 4? X to the 4, right? Be careful. We are adding those powers. X to the 4. Y to the fifth times y squared. Y to the 7. That's what goes in that first box. Go ahead and fill that in. And fill in the other two boxes as well. You are looking for the area of each box. We're multiplying its length by its width. Okay, so if you've got your boxes filled in, go ahead and check with mine. In the middle, I've got a negative 20. Wrong. Negative 28x to the 6th, y to the 5th. And then finally, 8x to the 5th, y to the 6th. Is that okay? Okay. So the final answer here, once you've got everything in the box, is to just write all that stuff out, but with additions and subtractions. I'm going to put a little plus sign in front of that 8, just to remind me that it is a positive 8. The other two guys were a negative, right? And so then our final answer is actually just written out here, is you just copy the stuff in the box. Negative 12x to the 4y to the 7, minus 28x to the 6y to the 5th, plus 8x to the 5th, y to the 6th. That is the answer for multiplying, for distributing the original problem. Okay? Like I said, this at the moment is more work than your normal easy distributing that you could have done before the box. Okay, let's use the box for a bigger multiplication problem. We're going to multiply 3x minus 4 by negative 2x plus 5. This is the FOIL kind of example, but we're not going to use FOIL. So take that 3x minus 4 and put it right out there. 3x in one row, the next term in another row, minus 4. The negative 2x plus 5 goes on the top, negative 2x on the first column, plus 5 on the second column. I'm going to make every effort to always write down the plus signs. That's a negative 4. Okay, and now we are going to find the areas of each of our boxes. So for example, let's take a look at this green box right here. What are the two dimensions for that box? Length 3x with negative 2x. We see that those are the two that create that box. We multiply those things together. What do we get? Try again. Negative 6x squared, right? Okay, let's focus on this red box right up here. Some of us are going to see right away what two things multiply, but some of us are going to need a little bit of a hint here. Clearly the 5, right? That's right next to this box, but where's the other thing? It's way over there at the 3x. Like you might have to look kind of far away, but that 3x is definitely the height, or the length of this box. So we multiply. 3x times positive 5 is 15x. See if you can go ahead and fill in the bottom two entries. Okay, bottom left, what is it? 8x. I'm going to try to follow the advice that I've already ignored. That 15x, what did I say I was going to try to do? Let's remember the plus. I've already forgotten my first plus sign. Put a plus 15x right there. How about that 8x? That is a positive 8x. And then negative 20. I think it's good to have signs on all of the things in the boxes. Okay, so our answer is right there. We just have to write all the terms out. I'm going to write it here, and then we're going to write the simplified answer. So negative 6x squared plus 15x plus 8x minus 20. That is exactly what you would have gotten if you had FOILed. Same answer, same pieces. And then Jeff is right, we need to combine like terms, right? 15x right there and 8x right there. We'll smush them together. That's pretty typical. Negative 6x squared plus 23x minus 20. One nice little thing about using the box is that the like terms are always going to appear on the diagonals as long as you're looking at the correct diagonals. So you can see in this case, those are my like terms. If the box were bigger, I would actually have other like terms on this diagonal and other like terms on this diagonal, and all of those diagonals would have like terms. We'll see them later on, okay? All right, I mentioned that there's going to be hard problems coming up. I'll just tell you what they are. It's me giving you this, negative 6x squared plus 23x minus 20, and asking you to figure out what. Go backwards. Can you figure out, hey, I'm telling you, I multiplied two things together and got that. Can you figure out that the two things I multiplied were 3x minus 4 and negative 2x plus 5? That's hard. We'll get there. I'll give you a process. I'll give you a process, but it's hard. Okay, so if we wanted to multiply, we're not going to write this all out, but if you wanted to multiply that thing right there times this thing right here, remember every term is going to give you a row or a column, so how many rows are we going to have? 3 rows, 3 terms. How many columns are we going to have? 4. So that would be a big 3 by 4 box, okay? All right, last example is on the next page. It says first we're going to fill in the outsides of this box. So highlight, we're multiplying this yellow thing by this green thing here. So go ahead and put the yellow stuff on the far left. And then the green stuff across the top. How many little boxes are inside the big box? 12. All right, I'm not going to ask you to do all 12 here. I think I will in the activity, but you just do 12 multiplications and you fill it all in. I want us to focus on that one that's kind of in the oval there. Can you figure out what two things get multiplied and then put your answer in that oval? I think I hear a few folks saying it. What are the two things we're multiplying? negative 6x by 5x, and we get negative 30x. That's good. That's what you multiply. Okay, Isabella? Squared. I wasn't done. Thank you. Squared. Yeah, that's good. And like I said, if you were to fill in the rest of the box, you would find the like terms that go with that one on that diagonal. It's really nice how everything lines up. Okay, I think that is good. So you are going to jump to the next page. And you are going to simplify just a couple of the quadratic formula type things that we started with, and then you're going to spend the bulk of the time doing this distributing thing. Again, I'm not ever going to require anybody to do the box, but we're going somewhere helpful. So I would recommend using a box at least half of these problems here, and the same thing on the homework.